now I think it's time to get started. Surface-based 3D modeling and visualization. Actually, our course material, including lecture and lab exercise, they are kind of overlapped week by week. Something elaborated from last week, and new things in roughly generated and highly overviewed. And next week, elaborated something from last week and new things, introductory, something like that. So some parts overlapped, some parts totally new, so that your learning curve is gonna get higher and appropriately given. So surface-based 3D modeling, I know what, you guys know what it is, but let's review using Google. Google SketchUp Summary as a surface-based 3D tool. In other words, polygon-based. Google SketchUp Pro is polygon-based 3D model. Last week, I showed you this diagram. What we believed, just 2D drawing, front view, top view, left view, elevation. When we believed they are design, the design tool was exactly the same, just AutoCAD. That's the first one. But people have been realized that 3D surface-based representation is design. So that's SketchUp and 3D Max. Surface-based 3D visualization software. And move to something advanced. But I told you, this semester, our focus is here, visualization, geometric surface modeling, and rendering using SketchUp, mostly 3D Max. This is 3D Max SketchUp overview. It looks solid, but inside of that model is hollow because it has only surface. But solid models are always solid, even if it cuts out, something like that, in shape. But actually, SketchUp 3D Max, if we slice the model, auto-generated surface can be generated. So in our site, it looks like solid, but mathematically it's some surface-based. Even if it looks solid, anyway, Max, SketchUp, they are all surface-based model, not solid 3D. So using that surfaces, a stack of surfaces, we create this kind of building, product, design, whatever. In terms of that concept, in mathematical definition, there are a bunch of vertices. 2 vertices generate 1 edge, and at least 3 edges generate 1 face. So now we have any type of shape. So this rectangle shape is 1 polygon. 1 polygon and group of polygon will generate this kind of 3D surface object. Edges, faces, that's why we call it surface-based 3D model. Similarly, we call it polygon-based 3D model. In polygon-based 3D model or surface-based 3D model, I told you vertex, edge, face, that's geometric shape in that definition. So even if we saw this kind of rounded shape, when we're zooming in, they are all straight lines, series of straight lines, because we believe that is curved because it looks like a curve, but in detail, they are not curved because they are straight edges, series of straight edges based on series of vertices, so that they can create new surface. How about this kind of something freeform or very smoothed surface? They are still edge and polygon. In other words, face-based model. Any type of organic shapes in this definition, they are still straight line-based 3D. Straight lines generates series of straight or flat surface. It looks like curve and freeform or organic shape, but they are still straight line base. How about this kind of structure? Of course, faces and their combination will generate that kind of shape. Even this kind of complicated freeform-like surface also bunch of series of surfaces. Some students from Poland in the morning class, today's morning class, she told me that how to pronounce some Polish names, so that's why I put this note, Rykulski. That was correct name of somebody in our class. But we can represent in Korean characters, except one, what I wrote here, this one, Yul. Yul. No one can write in Korean character. Except this pronunciation, we can put down anything without any problem in Korean characters. This one, Yul. No one can write in Korean, right? But anything else, Russian, even African, something like that, Rykulski, we can write down anything. That's the power of Korean characters, Hangul. But except this one, Il. Anyway, just simply think about this kind of surface, whatever it's organic. Its basic shape, basic component module is something basic shape. Do you know what's the basic component, basic shape composed of this kind of any freeform shape? Triangular or rectangle? Triangle? Triangle shape. Why? Anyone who can explain why? Extra points. What? Sorry. Try it. No problem. No sorry. No need to say sorry. If you say sorry in that way, somebody will die. Okay? Just try it. Why it should be triangle? I mean, we usually draw some meshes in this kind of shape. So sometimes we confuse that. Okay, the mesh looks like rectangle. So basic component, basic geometry, foundation geometry going to be rectangle. But actually, it's not true. They should be triangular shape. I mean, this kind of triangle, like this. Why? Try to explain it so that you can get extra points. What? What? Hmm? Need only 3 edges? Is there any specific reason why we need 3 edges only instead of 4 edges?
That's the least number of edges we need, or to make flat.
Okay. I think I heard main keyword, so that's correct answer. But even in detail, I'm going to explain why. Okay, this is X, Y, Z, Cartesian coordinate point, Cartesian coordinate system. Okay, in this 3D world, just simply think about there are 3 points or 4 points. Okay, now we have 4 points. Any kind of random 4 points. And try to make one single surface. Sometimes possible, randomly, in stochastic way, very low possibility. In other words, simply imagine your 3D world in your brain. But what if there are only 3 points? One single plane, always, without any exception, in mathematical definition. Do you understand? Really? Okay, great. If we have 3 points, this is triangular shape, but simply think about huge plane. Something like UV plane. Actually, this plane is XY plane, and this plane is YZ plane. But we can draw new type of plane. That's going to be UV plane. In other words, something here, UV. Exactly on top of this plane, all 3 points. This is always flat because it's triangular shape. But what if we have another one? Fortunately, it can be located on top of this UV, but stochastically, very low possibility. This one can be located anywhere. That means this surface should be bended if we draw exactly on top of one single plane. Not flat. This one always bended, but this one always flat, okay? We saw how it works. So bunch of flat triangles make this kind of surface. That's surface model, okay? Very simple. But in mathematical definition or some description, sometimes it's very hard to understand, but at this level, it's kind of piece of cake. Just simply think about flat and straight. Lines, flat, surface. 3-point base. Okay, all surfaces are actually flat. The title here means exactly what it is over there. And we would like to review something more about SketchUp. My intention for this is kind of review. I know you already got SketchUp techniques and some experiences in making something using SketchUp. But I would like to put more notes about SketchUp. I don't want to talk about some details or some theoretical parts. This is some technical aspects of SketchUp. Okay, first thing is accuracy and dimension and the main concept of scale. In 2D floor plan or CAD drawing, accuracy and dimension and scale, the one term for those concepts is simply scale. The concept of scale is the most important thing. Somebody thinks that AutoCAD has very precision drawing. In other words, it's very accurate. But SketchUp doesn't. But actually, it's not true. SketchUp also supports very accurate drawing and modeling. Precision drawing by SketchUp. So you can type those kind of numbers. Type 1000 means 1000 millimeter, or 1 m represents 1 meter, 4 meter, or 6 dash means 6 inch, something like that. You can type star 10, which means multiply 10, or /3 means divide 3, something like that. Comma means xy, even xyz coordinate points. So 4m by comma 5m means 4 meter by 5 meter rectangle, something like that. Double clicking of push-pull makes some exactly same dimension from the last double clicking, something like that. Same offset and snapping, measurement tool and protractor, and so on. Just one page. Tips for SketchUp, guidelines and axis tools, and so on. Amount of utilities, useful tools are there. Some more tips, precision control for vertex, edge, and face. Now we see geometric term, what we have learned from surface modeling, vertex, edge, face. In this kind of surface-based model, they call them exactly same, vertex, edge, and face for geometric modeling. So you can use kind of snap point using some vertices and copy edges, select edges, and push-pull faces. That's why we call it surface-based model or polygon-based model. And use components. We're going to do this kind of lab exercises in today's lab exercise hours. But now I would like to quickly overview what we have to do and kind of review purpose. Probably you already know what are they. Try to make components all the time whenever you create some geometry. In other words, whenever you create 4 edges and 1 face and push-pull to create a cube, it's supposed to be transformed to component so that you can control it properly later. Otherwise, you have to click or select one by one edge, face by face, and so on. It's not easy to control. We will review that in lab exercise hours. Amount of animation-related things in SketchUp, animation, add a scene, and so on. Also, AutoCAD-like layers are very useful in 3D modeling in SketchUp. Amount of style options, I think you already know and used it. And some more things. Shadow casting and shadow simulation. That makes your SketchUp slower, but sometimes it's very useful to cast shadows and so on. So there is something about modeling. Now we move to 3D rendering. 3D rendering using V-Ray plugin. Actually, we already did it, but this is a kind of overlapped review. Tutorials, amount of tutorials in Google YouTube. Google 3D, Google SketchUp, and Google YouTube. That's why we have to use Google. Whenever you want to create some specific shape and you don't know how to do that, but you are ready to know in 5 minutes, because we have Google and YouTube, just type it. SketchUp, sphere, modeling, that's it. And then tutorial video will show you how to draw model sphere. There is no sphere option in SketchUp, right? There is no way to create sphere, but you are ready to learn status, even if you don't know right now. That's very important. Now you don't know how to do that, what to do that, but thanks to this kind of tutorial and Google, you're going to be someone who knows it in probably 3 minutes. Something like Matrix, plug in, learn, do it. Why? That's true, believe me, okay? That's simple case, but what if very complicated case? Exactly same. Just type the keywords, what you're gonna do. SketchUp, something, 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 and Google will show you. Because in the world, among people, of course there are amount of people, at least hundreds, thousands of people, someone who has the same curiosity, exactly same to you. At least one of them posted how they resolved that problem. Thanks to their knowledge, their record, we can learn again, not from neighbor, okay? There are something in neighbor, but they are elementary school boys. That's what I told you, okay? This one, another example. Something about V-Ray. If you are curious how to use V-Ray, what is V-Ray, how to download V-Ray demo version, all answers are still there. This one from V-Ray website, Chaos Group. I'm not sure the company name. Anyway, rendered by V-Ray in SketchUp. This is SketchUp model and 3D rendering done by V-Ray. This one too. The example from V-Ray website under the SketchUp category. vray.com is the website. And another example, 3D warehouse. You know what's 3D warehouse, and you already took advantages of using this 3D warehouse. But this is just SketchUp model with some SketchUp material. No V-Ray related things assigned. What I mean is you can download some final model from this warehouse, but even if you render it using V-Ray, no reflection, refraction, or no special effects defined in V-Ray because it's not V-Ray based, it's just SketchUp material based. But thanks to that predefined model, you can assign something only for V-Ray, and then you can move on for better visualization, something like this. Probably this one's gonna take very long time, but anyway. Another tip, plugins. V-Ray is still one type of plugin, not the pre-installed software. So whatever you download as a SketchUp plugin, you should know that website, forums.sketcheducation, but sketcheducation.com. From that website, access the website and type it. Okay, I would like to draw Bezier surface. Just type it. And then there is Bezier surface creator plugin on SketchUp. Someone program it using Ruby script language and upload it. So what you need to do is download them and copy them on the plugins folder on the Google SketchUp 8. And the interface will be created and you can use them. Just copy and paste, download and paste through that website. Even if we are dealing with only 3D Max, those are some series of bunch of SketchUp plugins and tools. Tips. I told you something about plugin, and again, renderer SketchUp plus V-Ray. On the vray.com, there is V-Ray manual on SketchUp. So you can review a bunch of useful resources through the website or through the manual using references and so on. Another review file, review slide, rendering basics, something about lights. I put an emphasis on 3 major objects. First one is light source, another one target objects, the last one camera. But I told you, camera is kind of our out of scope. We don't deal with the camera yet. Later on, we're going to do that. Target object, that is your geometric shape, your design, your interior, your building, your object. And lighting source, especially sunlight. So we're going to do something about lighting source, especially sunlight, using V-Ray and mental ray. And we're going to compare them. Even if their interface totally different, background theory, fundamental technique, they all same. That's what I told you before. And target objects, diffuse is the most important thing, and reflection, refraction, and so on. That's why I show you this diagram last week. Again, I put this one, lighting source, target objects, observer means camera. On the lighting source, 3 things, direct, indirect, environment. On the target objects, object surface and object interaction. Under the object surface, there are diffuse, reflection, refraction, self-illumination, special effects, and so on. Object interaction. Object interaction means interaction between lighting target or target, and so on. Shadow casting. Shadow casting, interaction between light and object. Without light, no shadow. Something like that. Caustics, new type of light when light source penetrating some glazing, glass-like object. Ambient occlusion. The terms are totally new or complicated, but you have to know those words, those terminology, and then you can learn any kind of renderers, including mental ray, V-ray, whatever. So this is kind of expansion of this one. Under direct illumination, there are sunlight, spotlight. Under indirect illumination, there are omni, free light, diffuse reflection from objects, and so on. Object surface, there are diffuse reflection, but under diffuse, there are color, intensity, texture, bitmap, transparency. The same words under reflection, color, intensity, texture, bitmap, image, glossiness, and so on. You should know this even later, because in V-ray interface or mental ray interface, you may find out those terms, okay? So that is why you have to know what it is, especially very important things. So let's take a look at one by one, very important things here. First one is diffuse. Diffuse on the target objects. And I told you, without diffuse, we cannot see anything. Diffuse simply say the color of target object. So if you assign red color in diffuse definition, that's going to be red object. If you assign black, that's going to be black, something like that. So this is V-ray interface. And we're going to move our interface, our renderer to mental ray. But eventually, they are technically same, even if they look totally different. On the diffuse, two things very important. Its color and its texture map. Texture map, small m means no texture assigned, but large M means material, texture, image assigned. So click it, browse it, assign it in a certain way. That's exactly same to 3D Max interface too. So on the diffuse, color, texture map, transparency, they are important. But simply, on the transparency, white means transparent, black means opaque. 100 transparent, 0% transparent in black. What if this is reflection? White means 100% reflective and vice versa. And there is a concept of BRDF, bidirectional reflectance distribution function. That's here, developed by Newton or some similar mathematicians. I don't know. Anyway, thanks to this kind of equation, computers can compute its reflection angle, reflection color, amount of brightness, amount of color, and so on, so that computer can regenerate almost 100% same to our real world. That's what I introduced you last week. Let's move to reflection. On the reflection menu or reflection options, again, reflection color means reflection color. White means 100% transparent. Black means 0% transparent. In other words, it's opaque. Another important thing is reflection glossiness. Take a look at this glossiness. Now you understand what's glossiness. Last week we roughly looked at it, but now you know close to 1, it's 100% gloss. I mean, high glossy. high glossy and very low glossy, but it's still reflective. So you can control that number of glossiness so that your material looks realistic. This is reflection glossiness. So on the on the reflection rollout menu, you can take advantages of some of those important aspects. How about refraction? On the refraction, refraction transparency means not the diffuse transparency. If you want to make sure your object's transparent, you have to control diffuse, not refraction, okay? You have to control diffuse first, make it transparent, and make this refraction. Under refraction, only IOR and fog multiplier is important. IOR is index of refraction. Just take a look at the numbers. IOR, glass has 1.5. Vacuum, air, it's almost 1. No refracted. But diamond 2.4, emerald 1.5, water 1.3. That is why diamond, ruby, sapphire, they look different or look beautiful or whatever. But just remember, glass is 1.5. So default is 1.55. Simply imagine this transparent thing is kind of glass. How about, okay, the IOL, refraction IOL will show you something like this. One, no refraction, and some banded. Take a look at that angle and some different shape according to its IOL numbers. How about fog multiplier? 0, no foggy view. It's not foggy. No fog, but close to bigger than 0. It's gonna get some foggy and dimmed. So you can control this one too. So today's lab exercise, we're gonna deal with this one together with for the others we have learned before, especially in V-Ray plus SketchUp options. Okay, let's again move back to the course material. Refraction, IOR, fog multiplier. This example image from V-Ray website, actually. So you can refer to that V-Ray website manual and so on for your information. If you have some curiosity how to control the other numbers, you can simply try it or Google it, and then you can see variation according to changed, updated numbers, values, colors, and so on. So, but only few things you have to take care of when you are doing some V-Ray rendering. That's what I put the note here. Okay, let's move to the next one. Emissive is self-illumination. So intensity, the power of that light, something like that, is defined here. Of course, 0, close to 0, no emissive lights, brighter, bigger numbers. Only that intensity and double side. Why double side? This is not solid object. This is surface. Thousands of rectangular shapes. Series of triangular shape is one surface for this sphere bulb. Two side, double side means bright emission, external, internal. So sometimes whenever you intensity changed to 10, 100, 1000, nothing changed because inside lights only turned on. In that case, check double side or flip that surface. Flip the surface. Flipping surface is common in 3D Max. Sometimes you draw a box and you delete one side and you place a camera inside, pretending it's kind of interior, but nothing visible because that surface should be flipped. That's kind of problem of that surface modeling. But for reducing computer memory and reducing computing time, usually surface has only one side visualization in terms of computation. So that's why we have to take care of side direction. And this is a kind of proof that this tool is surface-based model. If this is solid bulb and solid model, there is no side, just one direction, because entire interior is solid. We don't need to take care of that because nothing can be inside in that surface. Simply because it's solid. Even in real world, this bulb has its thickness. 1 or half millimeter, even if it's very thin. Anyway, it's solid. Even if it's hollow, it doesn't mean that it's surface-based model. Even a brain, very thin surface, it has thickness, even if it's a nanometer, okay? That's our real world. In real world, there is no concept of surface. Surface has zero thickness. Nothing zero thickness in real world. Surface is kind of mathematical concept. It exists in our brain, mathematical world, not real world. You should know that. But solid objects all around in our real world. So when we are modeling, designing something, we have to use solid modelers. That's BIM, Revit, ArchiCAD, so-called BIM software adapted, okay? In that kind of software, there is no way to create zero thickness surface because no zero thickness surface are existing in real world. Okay, let's get back to the slide. Emissive, only 2 things we need to take care of, and some more V-Ray render tips when we are using SketchUp. We're going to do this one in lab exercise hours. First one is PNG files. I think you know PNG files. Also JPG files, GIF files, and so on. PNG supports transparent background. When we see this kind of pattern, gray, white, that means that part is transparent, nothing. So when you save SketchUp render file in PNG format, you can find out this kind of hollow, which has totally transparent. In that case, you can easily compose exterior view or background scenery, whatever. But when you save this one in JPG format, it's white color. And black field, another one, alpha channel image also created. But I recommend you to use PNG file as always. You can use GIF file, but the problem of GIF file is it supports only 256 colors, limited colors. But this one supports natural, true colors. But JPG couldn't support transparent background. So easy and explicit answer, PNG is the most good image format for designers. JPG is good for digital camera and common use, of course. And next thing is texture mapping things. Whenever you assign texture, right click on the texture position, we can control red, blue, yellow, green, so that we can skewing, scaling, moving, and so on, controlling texture map. Texture map is something about diffuse. But let me get back to the diagram I provide you here. Okay, texture bitmap image. Texture map under diffuse. Texture map under reflection. Texture map under refraction. Possibly some other parts we can find out texture map. texture map on the diffuse means how it looks like. Texture map on the reflection, in other words, black, white pattern means reflection gonna be made in that way. Reflection, no reflection, reflection, no reflection, in that way. Reflection, refraction, same. Okay? We're gonna test it. Texture mapping is very important too, but SketchUp has its own interface, something like this, but basically same interface in Max, Mental Ray, or even V-Ray in Max. But the concept, texture map, is one of the very important aspects of diffuse reflection, refraction. That's same, all same. On the texture mapping, there are a bunch of special effects or some additional effects. This is one representative effect, bump and displacement. Take a look at this one, left one, right one. This one looks something realistic, but it looks flat. But this one has its own embossed surface. Geometry, totally same, just a rectangle shape, but box shape. But this one, thanks to this bump map, it looks like something realistic. According to this light source, dark, bright, dark, because lights cannot get there, something like that, because of that map. Displacement is similar to that one. This is bump map. White, embossed, black, some deeper depths as original image looks like. We're gonna test it, not actually today, later, but this is one important thing we have to use later, so I mentioned this one when we are dealing with this kind of texture mapping. But as I told you before, SketchUp couldn't support bump map or displacement map because SketchUp texture map is only just simple texture because it uses material window defined in SketchUp. But under the maps option in V-Ray, we can control it. That's very important aspect. Another one, dynamic SketchUp component. We're gonna test it, see it, what it is.